In example 13.4, a robotic lander with an Earth weight of 3,430 newtons is sent to Mars. We'd like to find the weight of the lander on the Martian surface and the acceleration there due to gravity. We're given the radius of Mars and the mass of Mars. So the two equations we'll need for this problem are equation 13.3, which relates the weight on the planet to the mass of the planet and the radius of the planet, and the familiar equation that the force of gravity is simply m times the acceleration of gravity. So using this equation, we can solve for the mass of the lander. It has this weight on Earth, so we divide by 9.8 meters per second squared, and we find that the mass is 350 kilograms. Plugging into this equation, we get 1.3 times 10 to the 3 newtons. We can now calculate the acceleration of gravity near the Martian surface, and of course we put in this force and divide by the mass of the lander, and we get 3.7 meters per second squared. This seems like a somewhat larger value than one would expect. The reason is the mass of the Earth is about 10 times bigger than this. However, the radius of the Earth is about a factor or 2 less than that of Mars, so there's some compensation due to the smaller denominator. And so we end up with an acceleration on the surface of Mars that's about 40% of that of Earth. And this ends example 13.4.